Welcome back. It's me, Mr. Treewind, and we're doing part 2 of the distance formula / Pythagorean theorem. I say that because the two things are essentially the same. So I'm going to do the same, we'll do one problem, and I'm going to do two different ways. I'm going to use the Pythagorean theorem to do it. I'm going to use the distance formula. I'm going to show you how those two are connected and show you which one I prefer and how I use it, and then I'll let you figure out which one works best for you. So in doing this, yesterday we had a problem where we had a baseball field and we had to figure out the distance from home plate where the batter was standing to shortstop where he hits the ball and find the distance between the two. Well, today what we're going to do is we're going to do the same exact problem, same style problem, except this time we're not going to have a graph. We're just going to have 2 points. So I'm just going to make up some numbers. I'm going to write down 2 points on a graph, and then what we're going to do is we're going to figure out the distance between them. But we're not going to use any type of drawing. We're just going to simply use the Pythagorean theorem, and we're going to use the distance formula. And again, it's up to you. You figure out which one works best for you. So right now I'm going to pick 2 random points, and I'll go with, let's choose a couple negative numbers. How about -3, 7, and how about, I don't know, +9, -2. All right, now each of these 2 points represent a place on a graph. And this is very similar like in your car when you have GPS or on your phone and you say, all right, I'm at home and I want to go to the mall, and you type in the mall and it gives the exact distance. And then as you drive in your car, you notice that distance keeps changing as you get closer and closer to your destination. Well, that's because in your car or on your phone or whatever you're using to do this, your mapping device, all it's doing is recalculating the distance formula or the Pythagorean theorem, whatever one you want to go with. It's just redoing that every time you stop at a traffic light. It's just recalculating it. In fact, it doesn't even wait for you to stop at a traffic light. It's constantly calculating it because it's a computer, and it's really easy for a computer to continuously loop doing the same problem over and over and over again. But all it's doing is finding the distance formula. So how it works is we have our first number, which is our x value, and then we have our y value. And this marks one location, and then the next one marks our second location. And we're just going to figure out how to connect those 2 dots and what's the distance between them. And this is exactly, like I said, what's going on in your car, except in your car we don't use x and y, we use latitude and longitude, which is the same exact thing. It's just done on the scale of the earth versus like a piece of graph paper. All right, so if I want to use the distance formula, what I need to do is I would want to assign one of these to be x1 and then a y1, and we'll call this x2 and a y2. And what I need to do is I need to subtract them and find the difference between them. So writing it out, we're going to write, and the formula says I take my second x and I subtract my first x, which in this case happens to be a negative number. So now I'm going to be subtracting a negative. And then the same thing goes for y. I'm going to take my second y and I'm going to subtract my first y. And then one of the reasons I don't like distance formula is it's just easy for kids to make a mistake with all these negatives. Sometimes you make just the slightest mistake because you're concentrated on getting everything in the right spot, and then you make this slight mistake with a symbol or a sign, and all of a sudden everything's messed up. So I'm going to show you in a moment why I like Pythagorean theorem. I'm just going to drop a hint there that I really like that better. But anyways, 9 take away or 9 subtract -3 is 12. Because remember, when you subtract a negative, it becomes positive, so I get 12. Over here, I have -2 subtract 7, which is -9. Now, as a math teacher, I can tell you the one thing that I see happen all the time is right here, somehow, some way, when somebody goes to do their calculation, that -9 squared comes out negative again. And that's normally the mistake that most kids make when they use the distance formula. If they get a negative number here, they forget, somehow they bring the negative down, and then everything gets wrecked. So let's be careful on that one. 12 times 12, though, we got 144. And then 9 times 9, we got 81. But it's -9 times -9, so it's +81. All right, we total them up on our calculator. We go 144 plus 81. We get 225. Then we hit shift square root, and the answer comes out to be 15 even. That's amazing. I actually chose two numbers that came out to a perfect square, if you will. All right, so again, just kind of highlighting the little pitfalls that we have when we do this problem. This right here, I got a lot of times I'll have kids say 6. That's you know, you got to keep track of that minus a negative. Over here, the same thing, I'll get kids say 3, you know, or they'll sometimes, it's just, there's so many little things they make mistakes with, just tiny little errors. They get the big idea, it's just little errors, and then those little errors, unfortunately, trickle down farther down the line, and then at the end, we get the wrong answer. So you gotta be very careful, especially when we do distance formula and we're using a lot of negatives. Just write everything out, write every step out, and make sure you check, use a calculator if you need to. If you know that you tend to make little errors, use that calculator, be sure. All right, so I get 15. All right, now I'm gonna show you a little bit my way of doing it, or my preferred method, which is Pythagorean theorem. So let me see if I can make this a little bit easier and still build on the same lessons we did at the beginning of the year, or the beginning of the week last week, which was looking at the length of a segment that just goes straight across a page, or a number line. All right, Pythagorean theorem, these two things are called the legs of the triangle. And C stands for the hypotenuse. And no, there's no spelling test on hypotenuse. We're just gonna do the best we can. But A squared and B squared are our legs. Well, in this case, A squared and B squared stand for, let's make A our distance from left to right, and our B the distance going horizontal or vertically up and down. So we have our horizontal distance, vertical distance. So let's look at that. In our numbers that we have, -3 to 9. So think about this, you're on a number line, the most basic number line from algebra. It starts down at the negatives, goes up to 0. If you're at -3 and you come across the number line and stop at the number 9, think about it, how far did you move? 3 spaces and 9 spaces, meaning you moved 12 spaces. Okay, now that's your A squared. Because A, let's let A be our values going left and right, horizontally across the page. All right, same thing here. I'm over at +7, and I'm gonna travel down the number line to -2. Well, remember, our length going back and forth or up and down cannot be a negative value. So if I go from +7 down to -2, I traveled 7, and then I traveled 2, meaning I traveled 9. And this is going to be our vertical value up and down. So 12 squared is 144. 81. And then like we talked about, how do you undo a square? Well, you use a square root. And we get 15. Now, I like this method a lot better, and it's mainly because of the fact that I'm reinforcing the fact that I'm going to continuously look at the number line, always thinking about the number line. 2, I don't really have to think about positives and negatives. All I got to think about is that's 3 spaces and that's 9 spaces, which means I did 12 spaces. And I don't have to worry about symbols. I don't have to worry about that, fret about that, going, oh no, am I getting my symbols wrong? Which one comes first? It doesn't matter. It doesn't matter which one comes first. I can take these numbers, flip them around. It doesn't matter. I mean, think about it in real life. If you drive from your house to the mall, that's a distance. Let's say that's 5 miles. If you drive from your mall back to the house, isn't that still 5 miles? It's not like it got any farther or shorter because you drove home. So distance, that's why I say there's no negative distance. That value is the same either way. So if I take these numbers and flip-flop them, it doesn't change anything. All right, so that's just my little wrap up of how to do distance formula and Pythagorean theorem. If you're looking at me all day long, I'm gonna do this. If you raise your hand and ask me to come to your desk and help you with that problem, I'm gonna go this way every time because I'm 3 and 9. I don't have to worry about all this subtracting, just 3 and 9. And I'll thank Pythagorean for that one. All right, so hope this helped, and this should be the end of this particular unit. So see you later.